All right. Thank you, Evgeny. Thank you for the organizers for including the paper in the program. And thank you all for tuning in. This is a joint work with Vikramaditya Data. And what we do in this work is we investigate the effects of mining pools concentration on asset prices. And let me start the motivation by walking you through our sort of thought process here. So cryptocurrencies are different from classical asset classes like commodities, equities, bonds, and currencies in several critical or important dimensions. And one such dimension is mining pools. So, so what we do in this work, we incorporate mining pools concentration in a standard asset pricing framework. So who are these mining pools? Mining pools are complex entities, and the blockchain itself, the protocol, is quite complex. But what we try to do here, we try to look at the ingredients that are important for concentrations, and the ingredients that are not important to concentration are not part of the work, therefore. And so who are these mining pools, or how do we view these mining pools? We view mining pools as intermediaries, meaning that they provide access to households, they provide access to services. And so one particular aspect of mining pools that is very important for concentration is the fact that they are repeatedly compete with each other for the right to record the next block of transaction. And again, I don't want to get into the details of how does exactly that it works, because it is not directly related to concentration. And so as one might expect, as we see these advances in technology, the competition between mining pools is going to be intensifying. And so over time, we would expect to see significant variations in mining pools concentration. And this graph verifies this intuition. And so here on the y-axis, you see the HHI index for daily mining pools concentration, Bitcoin concentration. And the question we are trying to answer in this work, or the main thing that we are going to focus in this work, is how does this mining pools concentration are going to affect the cryptocurrency price and volatility? And the answer to this question, I mean, it's not quite straightforward. If I would ask you, how would you expect this to go? Without a model, it's going to be difficult to sort of figure out how this effect may go. And this question has yet to be addressed in the literature. And so another aspect of cryptocurrencies, which is not unique to cryptocurrencies, but it is important part of it, is what's called this interdependency. And so before I get into that, let's just first sort of look at how a cryptocurrency gains its value within the framework that we are discussing. And so the reason that households hold or would like to hold or to get access to cryptocurrencies is because the services this cryptocurrencies provide has value. And so the only reason, at least within this framework, the only reason to access cryptocurrencies is because the services they provide has value. And so cryptocurrency gains its value from all those future services that you will get from holding the cryptocurrency. But since the overall asset class, cryptocurrencies in general, are a new asset class, the trust and reliability in cryptocurrencies is still something that people are testing. And so you may expect that the cryptocurrency price is a signal for quality. And so you may have this feedback loop that's saying prices increase, then we have more confidence in the Bitcoin and therefore more services. So we have this feedback loop because services determine prices, but prices also determine services. And just as anecdotal evidence, PayPal, Venmo, BNY Mellon, Visa, Tesla, and there are other examples where they provide their services after the Bitcoin price went through the roof, right? So that this is just as anecdotal evidence. And so this interdependency, what it does, it introduces a bubble into the cryptocurrency price. And in the context of this work, what we care about the sort of this interdependency, it is important only through the mining pools effects, right? So we really are after this mining pools concentration effect on prices. And we introduce this bubble to see how these effects are going to change due to this interdependency. Okay, so how are we going to answer these questions? This is a theoretical study for mining pools concentration. It is a continuous time endowment economy, and we borrow a lot of the ingredients from the international finance literature. And so, as I said before, cryptocurrency is a claim on services. So the reason to hold the cryptocurrency is because it provides access to services. Interdependency means that the price goes up, then there would be more services due to prices going up. And so to make the model as simple and to really hone down on how this works, there are two mining pools. And think about, I mean, it's a theoretical concept, but think about a Lucas tree that generates this perishable goods or perishable services. And these mining pools, by mining, they are getting access to this tree. So if one mining pool's technology becomes better and better, it's going to get a bigger share of the service tree at the expense of the other pool. And so this is how the technological innovation is sort of modeled. It's exogenous, right? So the fact that one pool is going to get a bigger share from the other pool, it's a time-varying exogenous process. And we view it as changes to technological innovation. And so once the pools get access to these services, right? So they split this tree between them according to their technological innovation or relative to the technology. Once they want to trade those services with either with the other pool or with the households for trading purposes, these services are considered to be different goods. And this is trying to capture the fact that we have different preferences towards trading with bigger pools or towards trading with pools with different technologies from the supply side, or from the demand side. You would say, I would prefer to trade, as household would prefer to trade with a particular pool because it's located in a different, in a particular place, or some demand side effect. And so the difference between mining pools and households here is that households cannot directly get access to this service tree. So they cannot, without trading, they will not get any access to the service tree. The only way that these households can get access to services is through trading with the mining pools, and that's their role. And so, what are the main results? What we find is that as mining pools concentration increases, the volatility of the cryptocurrency is going to increase, and the price of the cryptocurrency is going to fall. And I'm going to show you some empirical evidence suggestive of these effects from the Bitcoin. And when we try to sort of look at how does this interdependency interact, so the interdependency is going to amplify this mining pool concentration effect on volatility and prices. And these results are due to the fact that we have results in precise closed form expressions. And so let's just briefly go over how this works. As I said, we have a Lucas tree that generates these perishable goods, which we call services. And there are two sources for these services. There is an exogenous source, unrelated to prices. And there is also an endogenous source, which is the cryptocurrency price. The cryptocurrency price is going to be an outcome of the model, right? And so we aggregate these two effects with the Cobb-Douglas aggregator. And this YT is the services. Beta is the parameter that controls the interdependency. And so this is an exogenous parameter, we choose it. And so if beta equals to 0, we are back into a multi-good endowment economy where there is no interdependency. And as beta gets closer and closer to 1, the interdependency effect is going to be stronger and stronger. What is the cryptocurrency price? The cryptocurrency price, as I sort of also mentioned before, it's a claim on all future services. It's a claim on this Y. And as I said, this Y depends on S as well. So this is where this feedback loop is getting in. And the cryptocurrency price, it's important to say, the cryptocurrency price is endogenous. It's not something that we choose. We sort of set up the framework and we're going to get what the cryptocurrency price is. How do these agents or participants in this economy are deriving their utility? The mining pools derive utility from consuming their own goods, while the households derive utility from consuming both goods. We choose gamma 1 bigger than 1 to give a sense of how does the model behave, when there is a demand bias. We call this a demand bias. A demand bias towards trading with one pool as opposed to the other. If this makes things complicated, I mean, you could choose gamma 1 equal to 1 where there's no demand bias, and then you have a symmetric case where the agent would be wouldn't mind with which pool to trade. But just to give a sense of how the demand side works, we just choose gamma 1 bigger than 1. Okay, so as I said, once the households, once the mining pools gain access to the services, if they want to trade those services, they are considered to be different goods. And so if households wants to trade with a particular pool, they would have to pay the fees of that pool in order to trade with them. And so PIT is going to be the fees that pool charges in order to trade their own good. And the numeraire, since we are talking about a multi-good economy, we have to set up a numeraire, and we choose a numeraire which is sort of a world numeraire, if you want, which takes 1 unit of consumption good, if you will, 1 unit of consumption good of each pool times the size times the fees of that pool. And P bar is, we call it a fees index, and it's an exogenous parameter. So we choose what P bar is. Okay, so let's briefly go over the equilibrium. So lambda is the size of the pool, or how shocks propagate into the economy. And so as lambda 1 increases, we would say that pool 1 technology becomes better. And since there are only 2 pools, lambda 2 is going to decrease. And so if we look at the effect, so this is exogenous effect, right? So lambda 1 is moving due to shocks. This is how we chose it to sort of interact. But then the effect on fees is endogenous. It's not something that we determined. It's an equilibrium outcome. And we see here is that as the size of pool 1 increases, we see that the pools that this pool charges are going to decrease. And then you would say, okay, there are essentially 2 channels that are competing with each other. You have the size effect and you have the fees. The size is exogenous channel. So technologies of pool 1 becomes better, the size of that pool is going to increase. But the fees is an endogenous channel, and it goes on the other way. And so you may ask yourself, how does in equilibrium, if I look at prices overall, which effects dominate? And so if you look at the multiplication of these 2 effects, then if the multiplication goes up, these 2 competing effects are going to be increasing prices. If the multiplication goes down, the overall effect is going to decrease prices. And we call this multiplication pool revenue shares, because if you think about prices or fees times the size of the pool, this is sort of give a sense of revenues or revenue share, because we think about lambda 1 as the share of total revenues and not the overall revenues. And so, as you may expect, as revenue share increases, we see that the total effect is going to increase or decrease. And so, how does concentration sort of get into that picture? Well, as it turns out, the effect of revenues and concentration are exactly in line. So just to sort of make it as simpler, think about the case where gamma is equal to 1. There is no demand bias. And so this lambda 1 star is going to be exactly at 0.5. So everything is going to be symmetric. There's not going to be any tilt towards any side. And in that case, where lambda is equal to 1/2, it's exactly the case where concentration is minimized, right? Because the size of the 2 pools is equivalent. And so what happens is that concentration perfectly correlates with revenue shares. So instead of thinking about shocks propagations through revenue shares, I can always think about it as shocks propagation through concentration. It's exactly the same sufficient statistics, if you will. And so let's see the implications of concentration. So here I see that, I mean, as I get into the middle, this is basically concentration decreases. And as concentration decreases towards the sort of the minimum concentration, which here is exactly where revenue shares are maximized, we see that the cryptocurrency price increases. And again, there are 2 competing effects, because when lambda 1 increases, it means that lambda 2 decreases. And so which of these competing effects is going to determine? It's exactly the same thing with fees, but instead of thinking about lambda 1 times lambda 1 P1, we could also look at lambda 1 and lambda 2. It's exactly the same thing. So the overall effect would be determined by whether concentration increases or decreases. So if I move towards the center, concentration decreases, and this is going to be the effect that is going to dominate. If I'm moving away from the center, the effect, the concentration increases, and the overall effect is going to decrease prices. And with volatility, we get the sort of mirror image. And as concentration decreases, we see the volatility decreases. And so now let's look at how these effects are going to be changing when we look at the interdependency. So the interdependency, as I sort of briefly showed, when beta increases, we have more interdependency. So here on the left graph, we see the sensitivity of technological or the sensitivity of the cryptocurrency price to technological shocks. And so we see that as I move between the lines, there is more interdependency. I see that the slope of this line is increasing, meaning that there is more sensitivity to concentration. So changes in concentration are going to be affecting total volatility more. This is one thing. So this is what I mean by increasing beta is going to increase the sensitivity to concentration. Well, when I go and look at prices, I need to distinguish between the two cases. There is this inflationary bubble and a deflationary bubble. With an inflationary bubble, the only thing that is going to pick whether I'm in inflationary or deflationary bubble is whether this fees index, which is an exogenous parameter, is high or low. And so if I choose this exogenous parameter to be high, I'm going to be in an inflationary bubble. And this is the case for an inflationary bubble. And so you see that when I move between the lines, I see that the cryptocurrency is becoming more sensitive to concentration. And you see that the slope or the changes in lambda are going to affect prices more. And this is what we mean by a stronger effect of concentration. In the deflationary bubble, we get the reverse. So when we are in deflationary bubble, meaning fees index is low, which is also, again, it's just parameter to the model, then we get exactly the reverse image. So when we move from no interdependency towards interdependency, the effects of concentration are going to be less important, or cryptocurrency price is going to be less sensitive to concentration. And so just to conclude, let me just give you briefly the suggestive evidence. So here on the left, on the y-axis, we plot the Bitcoin over Ethereum price. And here on the x-axis, we plot the HHI of Bitcoin mining pools. And this is quite, I mean, I don't think we could argue much with this picture that there is this inverse relationship between Bitcoin over Ethereum and the HHI of the Bitcoin price. And so just to give you some numbers, if I look at the correlation of Bitcoin over Ethereum and the HHI, we get a minus 63% negative correlation, meaning that HHI increases, the Bitcoin over Ethereum price is going to be decreasing in line with the model. If we look at the volatility of Bitcoin and the HHI, we see, as the model would predict, we see that the correlation is in fact positive. And here we are looking at, if you want, two different estimations. So if we try to think about a joint estimation where we look at a GARCH model, for instance, we get a similar result. So if we try to bothly estimate expected return and standard deviations, we get a similar result. Okay, so let me just conclude. This is a theoretical study of mining pools concentration. We find that an increase in mining pools concentration is going to reduce the cryptocurrency price, and it's going to increase its volatility. And we find that these effects are going to be amplified when there is more interdependency. And empirical evidence from Bitcoin verifies the model's predictions. Thank you very much. I'm looking forward to the discussion.